Hello everyone, welcome to TechWeb Talks. This is Graph Data Structure series and today I am going to discuss Dijkstra algorithm with single source shortest path with very easy code example. So let's move ahead without wasting time. So as you can see on the screen and all the users who are already a follower of this series, they already know I have covered all the green parts of this series, and today we are going to discuss Dijkstra algorithm. Okay, so let's move ahead without wasting time. Strongly recommend you to watch all the previous recorded sessions to understand in a better way. That will really help us. Okay, now why we are talking about Dijkstra algorithm. We know a graph is a greater data structure for storing the data for various maps such as cities and the distances between them. For this reason, one of the obvious real-world application of graph is searching for the shortest path between two locations, which takes into account a specific cost such as distance, the necessary time, or even the amount of fuel required. So all the definition, all the stuff that I'm discussing, it is very important, and you will agree with me on this, right? And we know about greedy algorithm. I have also discussed this thing in my previous videos, and that would basically find the cheapest local cost as it traverses the graph with the hopes that it would be globally optimum when it's done. Meaning a greedy algorithm would basically just take the first low value it sees, right? There are several approaches to the topic of searching the shortest path in a graph. However, one of the common solution is Dijkstra algorithm, which makes it possible to calculate distance from a starting node to all the nodes located in the graph. Okay, we will discuss on this in detail. Dijkstra is an algorithm created by a Dutch computer scientist Esker Dijkstra in 1956, and they published in 1959, designed to find the shortest path in graph without negative edge path cost. Remember this thing we are talking about, there should not be any negative path cost in the graph. Only in that case Dijkstra algorithm is useful, or you can say when we have negative value in the graph, in that case we cannot apply the Dijkstra algorithm. So you can say this is the disadvantage of Dijkstra algorithm as well. Okay, so Dijkstra algorithm solves a single source shortest path problem. When we are saying single source, it means we decide from where we need to start and where we will end. Okay, you can easily get not only the cost of connection between two nodes but also finds nodes that are between start and end nodes. So it always favors low cost paths. Okay, and one last important point is Dijkstra algorithm can only work with graphs that have positive values, that I already said. Negative values are not supported. This is because during the process the weights of edges have to be added to find the shortest path, and if any of the edges weight is in negative, definitely the output will not be correct. So that's why it is supported only for positive values. Okay, so let's move ahead. Dijkstra algorithm basically starts at the node that we choose, and we call it source start node, and it analyzes the graph to find the shortest path between that node and all other nodes in the graph with simple priority queue. Okay, that we will discuss, don't worry about that. The algorithm keeps track of currently known shortest distance from each node to source node. When we are talking about this, for example, we want to find the path from 1 to 7, so it means it keeps track of what is the value when we are reaching from 1 to 3, 3 to 4, 4 to 5, maybe 6, 7 or 8. So it is calculating every time what is the shortest path. Okay, once the algorithm has found the shortest path between the source node and another node, the node is marked as visited or relaxed, or you can say it is processed. So we can leave it, so we are not going to process that node again and add it to the path. Okay, when we are saying our node is 1, so we are talking about this is our starting node 1. Okay, so the sky blue color indicates it is the index of each node. For example, so index will start from 0, so we are saying 0 for 1, 2 for 3, and 1 for 2, and similarly for all other nodes. And when we are talking about weights, So we are saying if the node want to move from 1 to 3, so what is the weight? What is the distance between? 5. So after reaching node 3, we can say the weight for 3 is 5, right? In the same way, when we are talking about 1 to 2, so there is a 1 to 2, and what is the distance between this? 9. So weight is 9. So that's how initially we select the first node, and the index is 0 and the initial weight is 0. But here we have 5, here we have 9. So what Dijkstra algorithm says, out of these two, here we have weight 5, here we have weight 9. So we will pick the minimum one. Which one is minimum? The 5 one. Okay. So at the 5 node, 1 is already relaxed because we have already visited. After 3, we can only move 3 to 4. There is no other direction. Am I right? Okay. Now when we move from 3 to 4, the weight of this edge is 12. 12 plus 5 is equal to say 17. Correct? So now the 17 is the weight of 4. So now 3 is processed. Now when we move to 4, the weight of 4 is 17 and the weight of 2 is 9. So 9 is lower. Then we come here. Then we see from where we can go. From 2 to 1 we can go, and 2 to 4 we can go. If we process from 2 to 1, then the weight of 2 is already 9, and if we add 3, so it is 9 plus 3, 12. But the weight of 1 is already 0. So this is not the correct part. We will not update it and we will avoid it. Okay, to reach the 7. Okay, now we will check the path from 2 to 4. So we know the weight of 2 is 9 and the edge weight is 18. So 18 plus 9 is what? 18, 19, 20, and this is 27. But the weight of 4, not 4, is already 17, which is less than 25. So that's why, which is less than, what was 18, 19, 20? Yeah, which is less than 27. Okay, so then we will go with the 17 one. We will not update it. So at this point, we have processed node 1, 3, we have processed 2. Now we will process 4. Okay, from 4 node we have two direction. Again, from 4 we can go to node 2, from 4 we can go to node 8. So the value of that node is 17. We can say the total weight till here from 1 is 17, and if we go from 4 to 2, what is the weight? Is 17 plus 2, 19. But the weight of node 2 is already 9, so that's why we will not update it. We will say 9 is the optimum one, and if we'll do 17 plus 2, 19, so that will be the greater one. So definitely greater one we will avoid. Okay, because we want to find the shortest one. Now from 4 to 8, if we talk about, there is only one way, so we have to add 17 plus 8, it is 25. Okay, so 4 is processed now. Now we have 25 here. From 25, this is the only weight which is the minimum one. For rest of the node, for example 5, 6, 7, we don't know what is the actual weight, and initially we will consider we have the maximum weight allocated for these nodes, or you can say the infinity value assigned to 5, 6 and 7. Okay, now if we process the node 8, then from which direction we will go? We can go from 8 to 5 only. There is no other direction. So 25 plus 3, it is 28. Okay, so 28 is the new final cost of reaching from 1 to 5. So it is 28. Now 8 is processed. Now we will process the 5 one. So when we process 5, we can see there are many directions. From 5 we can go to 4, we can go to 6, we can go to 7, we can go to 8. So let's update, let's check one by one from where we can get the minimum cost, minimum shortest path. Okay, so 25 plus 9, it will be 37, and 17 is already assigned, so we will avoid it. We will not update the 17 one. From 5, if we check for the 6, 28 plus 2, it is 30, right? So there is no previously assigned weight for this 6, or you can say the shortest calculated value. So now it is 30. Okay, and if we check from 5 to 6, if we directly move from 5 to 6, because ultimately we are calculating the part from 1 to 7, so 28 plus 5, so it is 33. So we assign 33 here. But okay, and there is one more path which is 5 to 8. So now current is 28 and 3, and it is 31, but 25 is already minimum assigned, so we will not update it. Okay, so now our 5 node is processed, 5 is relaxed. Now what are the other minimum node which is available? This is 30, this is 33, and So only these two are available. So which one is lesser? 30 is lesser. So we will check from here. Now from if we can check if we check from 6, only one direction is available. From 6 we can go to 7. Okay, so 30 plus 1 is the weight between, so it is 31. And previously when we check from 5 to 7 it was 33, so we will update 33 to 31. Okay, so now the new updated value is 31. Correct. Now we will process the node 7. So from node 7 we can go to node 5 as well and node 6 as well. So now we have the new updated value, which is 31. So 31 plus 4, again it's 34, which is greater than 28. So we will not update it because we want the shortest cost. And from node 7 to 8, again we will add 31 plus 36. 31 plus 6, it will be 37, right? And the existing weight is 25. So then we can say 25 is better. So in this way we got the final path. As you can see, at this point we are not moving from 5 to 7 because at that point the total weight is 33, which is greater than 31, that we can achieve with via node 6. So this is the core explanation of Dijkstra algorithm. That's how it is designed. Okay, let's go to the another important points. So the process continues until all the nodes in the graph have been added to the path. This way we have the path that connects the source node to all other nodes following the shortest path possible to reach. Let's move next. So as I always said, the best way to explain is through an example, and I will strongly recommend you to watch all the previously created videos where I have explained the graph concept, how we can create graph, what are the important aspects of that. So to implement Dijkstra algorithm, the main rule is performed by this function, which is get shortest path Dijkstra. Okay, and I have used the priority queue, and which is a NuGet package, and you can get it from this URL. And don't worry about this, every information of this video you will get in the description of this video, even the GitHub source code link as well. Okay, so no worry about that. So let's jump into the Visual Studio to see all these things in action. So this is the same solution that I was using in my all previously recorded videos, and this is a simple ASP.NET Core application, and I haven't made any changes. I'm just using these classes and using the console to print all the output that I really want to showcase to you. Okay, so as you can see, we are talking about the weighted generic graph class. Okay, and in that I have added one method, which is the shortest path Dijkstra algorithm. Okay, in that what we are doing, how we are achieving the Dijkstra algorithm shortest path. Okay, so what we are doing, we have selected, okay, there will be one source node, there will be one target node from where to where we want to travel, or from where to where we want to calculate the minimum distance or the minimum cost. Okay, so what initially we are doing, I have created two integer arrays. One we call it previous, and we are setting its initial value -1 by using the simple fill method. Again we are creating second array, which is distances, and in that we are setting its default value is maximum of integer. Now I am setting the initial distance, which is from the starting node, will be 0. Correct, because the starting point at that time there is no cost, there is no distance, so that's why it is 0. Now I have created this simple priority queue, and as you can see, if I scroll up, you can see I am using this package, and you can download it, and link will be given in the description of this video. So after creating this priority queue, and what is the benefit of this priority queue, whenever we will update the priority, all the items will be arranged accordingly. So that's the advantage of simple priority queue in very simple ways. Okay, now in this priority queue node, in this object, I'm adding all my nodes, and you can see as a priority what we are giving it. It actually requires two parameters. One is the item, and second is the priority, right? In priority we are passing the distance, so whenever any distance is updated with the lesser value, so that will get the higher priority. Simple, correct? So all nodes are available here. So let me do one thing. Let me put a breakpoint here, so it will be very easy for you to understand. Let me run the solution. So here is our breakpoint. As you can see, till now what we did so far, we have created this integer array. Initial value is -1 for all the items. initial distance array, and the initial value is 0 because initially there is no weight, and for rest of them this is the maximum weight value, or you can say infinity one. Okay, correct. Now we are at this point, we have created the simple priority queue, and now what we are doing, we are just adding all those nodes with the distance in this priority queue object. Very simple one. Let me put next breakpoint here, hit F5. So my node is ready. If I expand here, we can see the first one is a node 1. It contains its neighbor 2 and 3, right? We have seen it. Now let's move ahead here. So while node count not equal to 0, hit F10. So what we are creating the weighted graph node here, and just pick one from this node queue. Okay, so it is picking one by one, and it is checking all the neighbors, which is the obviously the requirement, because without checking the neighbor and with its weight we cannot reach to the destination node, correct? Now secondly, after checking, okay, after getting the neighbor, we are checking what is the weight. We are doing the weight total, we are adding the weight from where we started and the edge that we are covering to reach the second node. So now here total weight is 9, correct? We have already discussed all these things. So what we are checking, if the distance is actually greater than 9, then we should update it. Now here you will see we are updating the priority. So as we move ahead in this whole algorithm, the moment we get the shortest edge value, so that will update the priority of each node, correct? You will agree with me on this. Okay, now similarly we will loop through each and every part. Whenever we get the higher value, okay, in this case from the total weight we will update it, otherwise we will avoid it. Okay, okay, let's put my next breakpoint here. It is very straightforward code, and I strongly recommend you, all this piece of code will be available on my GitHub repo. Take this piece of code and do as much experiment as you want, implement it in your solution wherever it requires, and just to understand the Dijkstra algorithm in a much better way. Okay, let me hit F5 here. Okay, again F5. I think I should remove breakpoint from here. Now at this point I can see all the node is processed, right? And we are creating one more list of integers, which is indices. So what I really want is from all the previous nodes, all the previous indexes from where we reach, it is 0, 1, 2 up to 7. Now what we are doing, we are creating a one variable which is of index type, and in this what we are setting here, the target value. Okay, the target value was 6 because we really want to check from index 0 to 6, or we can say node 1 to 7, because that's what we decided, correct? So index is 6, so it is saying 6 is greater than 0. Yes, in that case in indices list of integer array we are adding this index. Okay, that is perfectly fine. And we are also checking in the previously visited node, previously relaxed node, in that on this index what is the value. Okay, we will also get that, so it is 5. Okay, so we will update in this way until all the values updated in this list of indices. Okay, let me put my next breakpoint here, hit F5. Okay, now we can see we have got all the indices. What we really need is to reverse the order, because we really want to calculate from 1 to 7. So if we reverse it, we will get the correct order. Now the order is 0, 2, 3, 7, 4, 5, 6. This is the correct order. Now what we are doing, we are just going to add all the weighted edges, right, in this result object. So we have created a list of weighted edge. Okay, and at the end we are returning as a result from this method, so we can print on the console finally, correct? So if I return here, you can see total node 6, it is from 0, 1, 2 all the way to 5. So these all are the nodes that we covered, 1 to 3, 3 to 4 and 6 to 7. So total 6 we covered. So if we come here, so this is my startup class from where I generally explain all the previous concepts. In the same way I will explain this one as well. So we are talking about this Dijkstra algorithm. So I have commented all other section, so I believe you already know how to run this. All the sections which are here, I just commented one and just using the one which is required. So to check our Dijkstra algorithm is working correctly or not, so what we really need is a graph. Okay, so I have created this object of the weighted graph class. Okay, so I mean, to understanding this, definitely you have to go through my previous videos as well. So after creating this graph, I am adding all the nodes which are required all the way from 1 to 8. Very simple one. I am adding edges from node 1 to node 8. I mean all are the required path, either it is one way or two way, wherever it required. And then what I am doing, I am just simply printing to the console it is churning weighted graph, and we are also printing the adjacency list implementation of graph as well, that you can see, okay, with the help of this print graph method that I have already discussed in my previous videos. And the current focus is on Dijkstra algorithm shortest path, which really want to calculate from node 1 to 7, correct? So we will go here. What we are doing here, we are creating a list of edges, we are creating the name path, and what we are storing in this path object, maybe it's going to be the object of this one. We are calling the graph dot get shortest path Dijkstra, and in that we are passing node 0 and node 6. What is our node 0? Our node 0 is our node 1. What is node 6? Node 6 is actually nothing but the node 7. Okay, so that's what we want to calculate. Now we came here, now we know the result, now we have done all the nodes, and in simple path dot for each method we are calling, and it will print to the console. Okay, let me finally hit the run on this, continue. Here we can see the output, right? So in this you can see we have the adjacency list presentation, but our focus is on Dijkstra algorithm shortest path node 1 to 7, which is node 1, 3, 3, 4, 4, 8, 8, 5, 5, 6 and 6, 7. So I hope it is clear for you. Okay, so let's go back to the presentation. So here you can see we have discussed this one. So what was the output that you can really see? We talked about node 1 to 3, which is node 1 to 3, which is a minimum 5, then 17, it is a minimum 1, then 25, 28, 30 and 7. We avoid just this one because it is increasing the weight. So I hope it is clear for you. I hope you enjoy the video, and if you have any question, any doubt on this, you can just leave into the comment box. I will try to answer that. Your feedback is very important. That inspires me to create more such videos, and I will see you in the next video where I will discuss the game map implementation with the help of Dijkstra algorithm that we have already discussed. So see you in the next video. Till then, bye bye.